Hi and welcome back. Final video. This one is simply about the parallel circuits. So hopefully you should have seen this. Again, it's just the summary of series and parallel circuits. If you want to give it a read, pause the video and do that. This is a parallel circuit. So remember, as a series circuit only has one loop for the electrons to flow through, no junctions. A parallel circuit has junctions. It's got more than one loop. So I've got one loop here and then I've got a second loop there. So we'll go straight into the current. The first thing, remember, current is the speed the electrons are flowing, and straight away you should hopefully see that the speed is not the same all the way around a parallel circuit. It's quite fast up here and then it splits between two different loops. Slows down when it does that. Now we've got two loops here. You should hopefully, with a little bit of logic, be able to work this out. If those two loops are identical, what will the relationship be between the currents? So if I stick an ammeter in here, we can see that the current before the junction, before this point, is 1.8 amps. So if I have two identical paths that the electrons can flow through, what do you think the current will be on these two loops? Well, on the first loop you can see it's 0.9 amps. What do you think it will be on the second loop? 0.9 amps. So that's only the case because these two lamps are identical. But what you can say as a summary is the current before a junction is the same as the total current after. Sorry about that. So the current before the junction is equal to the sum of the current after. So 0.9 and 0.9 equals 1.8. Hopefully you should be able to work out at the end of the circuit what will happen. Well, that current and that current will add together. So if it was 0.9 on one loop and 0.9 on the second loop, the total combined current at the end is 1.8. So just if we add another loop, and I'll get rid of this one, something slightly different as to what you might expect does happen, but it is quite straightforward. Finish that loop off. We can see that the initial current actually jumps a little bit. You're not going to have to remember that. The reason it jumps is because I've added more electrons to the circuit. By adding another loop, I've got more electrons now, but the same thing still works. I've got 2.7 amps to start off with, 0.9 down the first loop, 0.9 down the second loop. What will happen to the third loop? .9. So the current before the junction is equal to the current after the junction, or the total current after the junction. 0.9 plus 0.9 plus 0.9 equals 2.7. These again don't have to be identical. I could give myself another lamp here. So daisy. I could give myself another lamp there, so that changes the currents, but you should still hopefully see a similar kind of pattern. 0.9 plus 0.9 plus 0.45 should, hopefully, fingers crossed, add up to 2.25. So the current before is still shared between those three different loops. It's just that one's got less now, less current, because I've got two lamps. Two lamps gives me more resistance. So more resistance means a slower current. Let me repair this circuit then, and what I'll actually do is we'll forget about you for now. We'll forget about that third loop and we'll just go back to the original two loop circuit, and I'll get rid of the ammeters just to try and make things look a little bit clearer. Okay, so back to the two loop circuit, and we've got to look at potential difference now. So with my circuit, my battery is supplying 9 volts once again. So again, think about this. Every electron coming out of that battery is transferred with transferring 9 volts of energy. So now look at this one. each electron travelling through this lamp should, in theory, be able to transfer 9 volts of energy. So what will the voltage of that lamp be? Not rocket science here, it's 9 volts. But every electron also coming through here also has 9 volts of energy. So what will its voltage be? 9 volts as well. So in a parallel circuit, you can see that the lamps are bright. They're the same brightness as if there was just one loop, and the reason being each electron has the same amount of energy to transfer to those lamps. So the summary for voltage in a parallel circuit is that the voltage supplied by the battery is the same on each of the loops. So if I add this loop in, hopefully we should see 9 volts supplied by the battery. Even this lamp will get 9 volts. Try it, come on Mr B, please. There we go. And once again, sorry, family emergency. So once again, the summary, the voltage supplied by the battery on a parallel circuit is the same for each of those different loops. Again, the lamps don't have to have 9 volts on there. If I stick another lamp in here, you can see these two lamps are unaffected, but these two now, what would their voltage be? 9 volts for the loop, so the electrons going through this lamp, will be able to give that lamp 4.5 and this one 4.5 as well. So just to recap, in a parallel circuit, the current before a junction is shared between the different junctions. The voltage supplied by the battery is the same for each of the different loops.